Hi, everyone, and thank you for joining us today for what should be a very interesting and informative session on augmented and virtual reality and its capabilities to transform your enterprise. My name is Mark Callan. I'm a sales manager here with InMinds. I'll be moderating today's webinar, and I am joined on the panel today by two of my colleagues, Anur Puniyani, who is our AR/VR domain expert, and Pradeep Gudapati, our Chief Technical Architect for Mobility Solutions. Before I turn it over to Anur, let me highlight our agenda for the webinar. Anur will begin with a bird's eye view of what AR and VR is, followed by an overview of the ecosystem and associated AR, VR hardware and software. We will then share XR adoption in the industry, highlighting specific business use cases InMinds has worked on and delivered for our clients. We will also take you through the XR implementation journey, skills required to build the applications, the challenges faced getting there, and the future of AR, VR within the enterprise. I'll then conclude with a brief overview of InMinds, who we are, what we do, and then we'll open up the webinar to questions from all of you at the end. Just a few administrative items to keep in mind. You can submit your questions at any point during this webinar on the control panel. You can also submit questions through the chat box as well, and we will address and answer all of those at the end of the presentation. There will also be several polling questions that I'll share with all of you during the course of this webinar. When a question pops up on your screen, simply click your response to submit your answer. With that said, let me turn it over to Anur to begin. Anur?
Yeah, thank you, Mark. So my name is Anur Punyani. I work here as the AR/VR domain expert, and I have over 10 years of experience working on games, simulations, and AR/VR applications. So, like Mark said, I'm just going to talk about a bird's eye view of the entire ecosystem of AR and VR, and set up the vocabulary for the rest of the session. So I'll start with a quick definition of a few of the terms. What is AR, VR, and what is mixed reality? So AR stands for augmented reality, which is nothing but overlaying images on top of the world. On top of the view of the world. This could be on a camera feed, or it could be on the actual world, which you see on a head-mounted display. What is virtual reality? Virtual reality is when you step into a simulated 3D environment in a head-mounted display, and your movement is very realistic. It tracks the virtual world changes as if you're actually making movements inside it. Now, what is mixed reality? Mixed reality is when the 3D objects, or 3D or 2D virtual objects, are not only overlaid on top of the real world, but they also interact with it. So, for example, if you place a 3D asset in the real world in augmented reality, then in mixed reality, the 3D object would actually interact with the lighting. I mean, the lighting would affect this 3D virtual object. Now, let me talk a little bit about the non-obvious differences between augmented and virtual reality here, because it is important from the implementation or the user perspective. So, augmented reality as of today presents far more usable instances as compared to virtual reality, and that is primarily because in VR, the user is disconnected from the world, and not only that, the user is completely engulfed in this virtual world. Now, what happens because of this is that one has to maintain even a small a deviation from the expected behavior is noticed very easily, and it can cause a lot of discomfort. I mean, when I mean expected behavior, is that when you look at the real world, you don't see frames dropping, right? I mean, you see a continuous view of the world. So in the world of virtual reality, this this effect gets highly accentuated, and any deviation from expected behavior of like what our senses are accustomed to seeing can cause nausea or a sense of disorientation. The same is not true for augmented reality, and that's why it's far more usable scenarios when it comes to AR and VR applications. Now, let me talk a little bit about the hardware. I will start from the bottom of the pyramid in terms of for AR and VR hardware. At the bottom come the mobile devices. Mobile devices can be used both for augmented reality as well as virtual reality. When it comes to VR, the mobile devices are coupled usually with a head-mounted display, which is often called a HMD, which we will call an HMD here on in this session. So a mobile device, to be a VR device, needs to be strapped onto an HMD, and the movement of the mobile device inside the HMD then informs or then supplies the input to display the virtual reality content on the mobile device. Now, an important difference when it comes to hardware is between tethered and untethered HMDs. What is a tethered HMD? A tethered HMD is a head-mounted display that requires a graphics-capable computer to be attached to be able to render at the speed and quality that is required for VR rendering. Usually, this is a fairly fairly high-end graphics-capable device which requires a graphics accelerated, a graphics card of at least a certain decent amount of capability. When it comes to untethered headsets, these are headsets which can do all of the rendering. And yeah, so I missed mentioning that for the tethered headsets there is also a set of motion sensors that you need to set up in order for the motion tracking to be done effectively. When it comes to untethered headsets, these are typically headsets which they don't need any external computer to be attached. All the computing, whether it is motion sensing or whether it is rendering, is all done on the headset itself. Uh, so the untethered headsets are still evolving, and they're still not, in terms of the fidelity, they are still not comparable to the tethered HMDs. When it comes to software, we have the two major smartphone device platforms, the iOS and Android, provide AR and VR support through their native SDKs. Then, in addition to the iOS and Android support, we have 3D game engines. Like chief amongst them is the Unity game engine. Unity has been a game engine of choice, a game engine, or I can also call it a gaming software for those who are not familiar with the term engine. It's a gaming IDE. Also, we can also call it an IDE for developing games. It has been a tool of choice for developing games on the mobile devices for a long time. And with the advent of AR and VR technology, it has extended its own capabilities to enable development of XR content on the engine. So yeah, one more term I introduced, if you missed, it's XR, which is extended reality, which is a all-encompassing term which includes AR, VR, and mixed reality. Another similar game engine to Unity is the Unreal game engine, which has also been a very popular game engine to develop games, not only for mobile devices but also for like the bigger gaming devices like gaming consoles and gaming PCs. And Unreal 2 has extended its capabilities to allow for creation of XR content. Next, let's talk about the AR VR ecosystem in terms of the hardware, the big hardware players and their products. One of the chief amongst them is the Oculus. Oculus has the manufacturer of the Oculus Rift HMD for VR rendering, and it has been amongst the first entrants into this VR HMD market, amongst the ones that made the biggest splash when they introduced their products. So they came out with the Oculus Rift in the mid 2016 timeline, and since then they have made improvements to this HMD, and they came out with the Oculus Rift S, which made several improvements in several different areas, including motion tracking and the rendering. And this was released in May 2019. So Oculus has also been working vigorously in the area of untethered VR. It released the Oculus Go, which was the first major untethered VR headset, a non-mobile untethered VR headset. Like I said before, a mobile device strapped onto uh, a VR HMD. So that is one type of untethered headset, but that's really not as capable as the ones that, like the Oculus Go, for example. So these are dedicated VR devices. They don't need a mobile device to be coupled to the HMD. So the Oculus Go was released in May 2018, and it was the first proper capable VR HMD. But beyond, Oculus then went on to release the Oculus Quest in May this year, and Oculus Quest has created a lot of waves in the market, and it has, especially by introducing 6 degree of freedom movement, motion tracking, it has been the first truly untethered VR headset which has the capabilities of an untethered VR headset. Next, we come to the AR side, where Microsoft is one of the major players in the market, and it released the HoloLens one in the year 2016 March, and the HoloLens is a AR HMD, augmented reality head-mounted display. Um, and then Microsoft went on to release the HoloLens 2 in May 2019. Next, we have the HTC, which is a VR HMD manufacturer and a close competitor to the Oculus. So HTC came out with the Vive, the first, a very high definition, highly capable VR headset in June 2016. The HTC Vive was a set. The bundle was a set of motion tracking sensors, a pair of controllers, as well as the actual HMD. Since then, the HTC has made several improvements on the initial release, and it released the Vive Pro in early 2018. In addition to the regular HMD, the regular VR HMD work, it has announced major innovations in the area of VR HMDs, and it unveiled the Vive Pro I in the Consumer Electronics Show in Jan this year, and it features a unique technology called foveated rendering. Now, foveated rendering is something which improves VR rendering capability by tracking the part of the HMD where the user has focused his or her vision, and increases the display, the image quality in that particular region, and the focus of the rendering now shifts to only that location. So it reduces the computation power heavily, and thus helps in achieving far higher rendering rates. Now, some other innovations that it has done or it is working on in the field of VR HMDs is that it has announced the Vive Focus, which is again a untethered VR HMD, and something very interesting called the Vive Cosmos, which has only been announced in the CES 2019. Vive Cosmos is a device for which you can, during your VR experience, you can just open a flap and get connected back to reality. So one of the challenges of VR tech in general is that users tend to get disconnected from their surroundings. Now, with an innovation like the Vive Cosmos, this may no longer be as big a problem, because users can immediately come back and connect back to reality by just opening a flap instead of having to remove the entire HMD. Next, we come to the second major player in AR HMD market, which is the Magic Leap. Magic Leap was a very mysterious startup which received close to $1 billion funding in spite of not having released its first product. So Magic Leap did eventually release its first product, which is the AR HMD, which was hyped up to be a very revolutionary AR HMD in August 2018. Unfortunately, it did not live up to its all the hype and all the expectations that were set for it. And but I mean, it is with the kind of backing that Magic Leap has, the kind of funding it has, it's very likely that something very revolutionary is going to come out from its stables very soon. Now let's look at the software ecosystem. In the software ecosystem consists of the two major smartphone manufacturers, smartphone platforms, Google and iOS. And so Google has, in addition to providing software capabilities in its Android SDK, it is also the creator of the Daydream VR platform, which is a low-cost Daydream phone-based VR headset, and a set of Daydream capable devices, which are devices which contain special hardware to be able to render VR experiences in a better way. So again, iOS provides native support for augmented reality development via the ARKit framework. And also there are rumors floating about that Apple is also working on its own VR solution, but these reports are not yet confirmed. Next, like I spoke about on the first slide, we have third-party AR and VR software creation tools like Unity and Unreal. So with Unity, what happens is that you don't need to really bother about your target platform. Unity can be used to deploy to a number of different target platforms, including iOS, Android, HTC, as well as your Oculus, the Oculus range of devices. So also with Unity, you get a lot of other capabilities, like being able to quickly prototype your AR experience without actually having to go back to the device each time you make a change. Very similar to Unity is the Unreal. Unreal also has a set of rich features for creation of AR and VR content. Then we have several small players in the market, small or medium, like you may call them small also. So there's something called Leap Motion, which is a device which manufactures and markets a device which recognizes hand gestures. So we also have Vuzix, Realwear, Athir, which are makers of smart glasses, and a lot of them are actually already adopted in the industry for enterprise purposes. Then we have something called the Amazon Sumerian, which allows you to create VR experiences without having any knowledge of creating graphics assets or of programming. So with that, I will hand it back to Mark. Over to you, Mark.
Thank you, Anor. I'll be posting our first polling question now, which you should see on your screen. What we'll do is we'll pause here for just 30 seconds to allow everyone to submit their answer before I close the poll, and then we'll continue with the presentation. So we'll give everyone about 15 more seconds. Okay, great. Thanks, everyone. So now I'll turn it over to Pradeep, our Chief Technical Architect, who will take you through our XR adoption in the industry. Pradeep?
Yeah. Hi, Mark. Thank you, Mark, for this. So, hello, everyone. My name is Pradeep. I have around 15 years of experience in the mobility industry, and the last few months have been exciting with XR technology is taking over a lot of scenarios. And I'll be talking about the adoption for enterprise, for personal, and a couple of case studies. So, I'll start with the enterprise adoption of XR. As Anur mentioned, XR encompasses both AR and VR. And based on research conducted recently, some of the estimates say that there will be close to around 1,000, so 120,000 stores by 2022 that is using AR globally. And this technology, that is AR, stands to influence as much as 3% of the e-commerce revenue by 2020 itself, that is next year. Another research conducted by Accenture states that the the expenditure on XR technology, that is developing XR solutions by the industry, that is enterprises or companies, is set to triple the level of consumer usage by 2023. So that means it's close to around $121 billion will be spent on AR and XR apps by the enterprise. Now, so what are the top industries that are using XR technology? The first and foremost, or the first usage of XR actually came into practice was in repair and maintenance slash automotive industry. So what happens here is for example, if there is a complex motor or a complex engine or some kind of complex device which needs repair or maintenance, and there are no field agents with the right expertise. In such cases, AR comes into the picture, and you have these head mount devices which have a camera and a earphone on the HMD device, and they call up the remote expert sitting in the other side of the world, for example, or somewhere else, and they will guide these field engineers to actually solve these complex problems. Now, there are many companies that are building platforms for this, and this is actually in use in a lot of automobile industries where high-end cars are involved, or in airline industries, etc. The next great use case for AR is in healthcare or medical training. Uh, it's from operating MRI equipment to performing complex surgeries. AR tech holds the potential to boost the depth and effectiveness of medical training in many areas. Actually, this is even in use right now in some of the hospitals where students are actually utilizing an AR headset to delve into the human body and understand anatomy using interactive 3D formats. The next famous or the most usage we see is in retail. And in today's physical retail environment, shoppers are actually using their smartphones more than ever to compare prices or look up additional information on products. In fact, a famous use case is that of Harley Davidson. They have built an XR application, AR application that allows shoppers to use it in the store. They can change colors, they can add customizations to the bike, and then based on their own liking, they would then order for that bike. Now, the next use case is tourism. Tourism has gone a long way towards advancing, in the using these advanced technologies, and some companies have actually built VR applications that allow you to do a virtual walkthrough of the tourist places. Like, for example, you're sitting at home here, and you can walk through pyramids of Giza, for example, or you can walk through Australia, or any such famous tourist places. Based on your experience of walking through these, then you could then buy your tickets to fly there. Or, for example, if a big a tourist company Cox and Kings, it gives you an app that allows you, or shows you a VR headset, allows you to go through this, then you actually have understood what it is actually, and whether you would be able to go through and enjoy the tourist location, and then decide on buying the tickets. So it has made life easier for many of these travel companies. The next one is design and modeling and real estate. From interior design to architecture and construction, AR is actually helping visualize their final products during the creative process itself. So, with the use of these HMD devices, architects, engineers, and design professionals step directly into these buildings and spaces to see how their designs actually look like. And this, and sometimes even they can virtually, look at the location, or look at these and spot some changes and make them right then and there. Urban planners can even model how entire cities look like, and using these AR headsets, and make changes whenever required. Any design and modeling jobs, that involve spatial relationships, are a perfect use case for XR technologies. The last final one use case that we'll talk about here is education. While technology like tablets have become widespread in many schools and classrooms, teachers and educators are actually ramping up students' learning experience with AR. There are multiple apps today in the app stores, and for in headsets, that allow students in a classroom to view, rich content of what they're learning about. For example, if they want to understand how an internal combustion engine works, in the book they'll have just some pictures, but with AR you can point a camera, you can point the app to this particular engine, and it would start showing up how a video looks like in a 3D format, or or a video in 2D itself. So all this is possible through AR and VR technologies, and industry is actually picking up, and it's coming to mainstream now. I'll talk about the next one, is the personal consumption. This is something that you have already seen. For example, games. Remember Pokemon Go, which came out a couple of years ago, and Pokemon Go is actually created sensation. In fact, there were a lot of people running around, aimlessly. In fact, we would see it as aimlessly, but they were actually looking and finding Pokemons all around the world. Another such game, like Pokemon, actually Pokemon is an AR application. Like Pokemon, there is another application on the App Store called as basketball. You could place a, for example, you could place a basket somewhere in your house, and then you could throw balls into that basket and make points. So similarly, like games, we have 3D movies also. You can have virtual. You can put on a camera into that. You can put your phone into into your HMD device, and like, for example, a Daydream device, and watch 3D movies in your headset. So it gives a more immersive experience. The next big use case of AR is social media. Snapchat, Instagram, these use filters. Those cat whiskers, for example, that's all AR, and it actually is a huge hit. And this actually, social media brought AR to the mainstream. So everybody who knows about AR may have not related that particular feature with AR, but that is AR, and that's how mainstream and famous it has brought these different technologies into picture. The next most useful for personal consumption is navigation. For example, Google Maps AR or Here Maps City Lens. They allow you point your camera to the location you are. It'll use AR technology to identify what's around you and then guide you to the right location. That's so intuitive and immersive. It actually is contextual. It's contextual. Basically, it allows you to be. It's not like a map, where you have to find. In the map, you'll look at the on the screen of your Android or iOS device, and you'll say, okay, I need to find where is the next landmark. So with AR, it automatically does everything for you and puts an arrow onto the screen and tells you, move left, take a left turn here or take a right turn here and walk towards your destination. The next big one is sign reading. So you are in a different country, you don't know the language or the script. You point your app, Google Translate or Google Lens or Office Lens. You point it to that particular sign, and it will translate and tell you what it means, what it's trying to tell you. And in fact, this uh, the navigation that I was talking about earlier was actually is actually making waves in Gatwick London Airport, and it actually helps the airport travelers to find their way within the airport, find the shopping zones, find the different terminals, their gates, and everything within that airport. The next big use case for personal consumption is home improvement. Magic Plan is one such solution. AR, this application allows you to make precise measurements. It allows you to create a professional floor plan with just a few clicks. Okay, and it helps you view your space in 3D, and it allows you to do DIY projects, for example, at home. So you don't need somebody's help to go and measure out, or find out what is the what kind of items you can put in your location, in your house or in your office. Similarly, there is IKEA's application, IKEA's product placement application. It creates a 3D true to scale models and furnitures, and it will allow you to place them in your home and feel how it will look like. So basically, these are all 3D true to scale models of sofas, armchairs, coffee tables, etc. And you can then directly order from there itself. So imagine how this would help people designing a new home. The next one is connecting people. Uh, uh, in today's world, we talk on phone, and I'm here with you. I'm giving you, a lot of information about XR, but then it's not, and there's no intimacy, there's no connection between you. So you might be doing something else now. But if I was doing it with XR technology, with a VR headset, for example, I would have direct eye contact with a lot of people. How much? Imagine how much this would affect communication. It would create trust. It would create trust because there is eye contact. And imagine talking to your kid or talking to your family sitting on the other side of the world. It creates that intimacy. It creates that feel that you are right then there and talking to them in front of each other. So that's one big system that is coming up. A lot of people are using it. Microsoft has recently showed a video on YouTube for this. It's great. The last and famous most used adoption is in real estate. In real estate, for example, there's high-end homes, etc. You create VR models or VR videos out of it, and then you can prospective buyers could actually watch how the house looks like using their VR headset. You could feel like you could, put it on the head, and it's like how I talked about earlier about tourism industry. In the same way, real estate also does make a lot of sense using VR. Now I'll go on to the next topics that that I'll talk about is our case studies. So what we have worked on, minds, we are having this webinar, and what is our experience? The first one that I'm talking about is for a client that we built. We built an XAR platform, which we are helping them build their AR platform, which looks into the domain of the repair and maintenance. For example, as I mentioned earlier, automobile industry or any industry that needs repair and maintenance, and they have experts sitting remotely and field engineers not that experienced. uses this kind of a solution, and we built it. So people think that AR means, oh, there's a lot of technology involved, there's a lot of different things that I don't know about. But no, it's pretty straightforward. The major components of this solution are simple standard solutions that we use for all other software applications. For example, we use, so to make a call between the remote engineer and the field engineer, we use WebRTC. So for that, we used an open source solution called as Jitsi to build that admin module and to build the the web application. So for example, the remote engineer could be sitting in front of a system, so for him to have access to a remote headset, I mean, the field engineer could be wearing a remote headset. So for him to make a call to the to the field engineer, he could use a web application. So we build that using Angular. Then there are Android and iOS applications. So if you don't have a headset, you could use it on your, you could use the AR tech on your Android and iOS native mobile applications. So he'll call the remote, the field engineer will call the remote expert, show the point the phone to the look to the place where he needs help in, and the remote engineer, the remote expert could annotate on the phone and tell him, oh, look here in the top right corner, I marked it like this in this yellow area. You have to look into that and fix it. So for an enterprise which needs to extend expert support to an engineer working on a field, this solution actually makes most sense. And some of the key results, we worked with multiple headsets. One of them is RealWear. We helped build almost 50 plus features, and we implemented something called as push notifications, which allows remote engineers to receive notifications that somebody is trying to call them, or field engineers receiving notifications that expert is trying to call them. Similarly, we implemented the task flows. Yeah. So moving on, I'll talk about the next case study that we have. It's for one of the biggest VR headset manufacturers, and we actually, our expertise lies in maintaining or creating a test lab which identified software and hardware combinations and configurations that would help test out these headsets. So as Anur mentioned earlier, some of these headsets require high-end graphics and high-end system configurations, and it'll not work if the specific frame rate is not achieved using that configuration. So we helped build, or we helped set up a default list of configurations for our customer, and we built it for them. So we not only did that, we did performance monitoring. We built a test automation framework that with reusable components for accelerating this testing cycle, and not just testing of these headsets and the configuration. We also built their app store. So you have a headset, but you don't have content. That makes no sense. So we built their app store for the Android and iOS applications, as well as the Windows and Mac desktop applications, wherein users could buy content. So different contents are available, videos, games, etc. for your VR. You pay for it on the application, this payment on the app store applications, and it would automatically get downloaded in the different clients that we have. So what are the key results here? We certified close to around 190 contents or apps on 30 plus GPU plus CPU configurations. We benchmarked close to around 7,000 such combinations. uh, we built, I mean, we tested all these configurations for Windows 10, 7, and 8.1, and we measured these performance using industry standard tools like NVIDIA's FCAT VR and Fraps tools. The key performance metrics that we included: unconstrained FPS, frames per second, average FPS, total frames, dropped frames, etc. And we qualify the titles based on their unconstrained and average FPS. We also created and reported functional and usability issues like launch failures, rendering, blurriness, crashes, etc. So that's about the case studies. I'll now hand it back to Mark.
Thanks, Pradeep. So let's pause here for our second polling question, which is now on your screen. We'll give everyone about 20 or so seconds to submit your answers, and then we'll close the poll and continue with the presentation. Great. Thanks, everyone. Back to you, Pradeep.
Yeah. So I'll move on. I'll start. I'll give you a brief about how AR implementation journey is all about, and what are the different stages involved in your AR implementation. So the first stage, that is the most important stage, is to understand what is AR and how it makes sense for your business challenge. Once we understand about AR, then we make a list. It's basically an inventory of all the potential use cases addressing your business challenges. So once you have the list, it then makes it easier for us to assess what are the items that need to be added to your application. We finalize the concept and we storyboard the whole process, so that makes it easier for us to understand what we need and how to build it. Now once you have assessed and have the the storyboard, we can then build a small POC that that tells you that this is a proof of concept, that basically this concept works, and then improve on it to create, at least it should, if it solves a couple of use cases, then it makes more sense, right? So once we have that POC, we know that the system works and it'll actually make sense. And that is when we start industrializing it. Basically we start putting into real world scenario. And at this point we actually need to build content. Now what is content? Content is actually that the 3D different 3D content development. It includes special effects, it includes music. So if it's a VR application, then it needs all these three items. If it's an AR application, it might need only the 3D content. For example, you have to show an arrow, so it's arrow showing the navigation to move to a particular location. Or if you have pop-ups coming up, so these are all coming under 3D content. If you have a And that's for AR only. For VR, you have, it's an imaginary world, remember. So in such scenarios, you need to recreate the whole world. So if you're, for example, if the user, you're creating a game or a movie that like you're driving a car in on a road, so you need to create the whole scenario there. So for this, you need to create music, you need to have the special effects, the graphics, the backgrounds, the textures, everything needs to be created. So all this is done at that point. So once you have the content ready, you need to place them in the right spots, right? So how do you place them? That is where you use technology like either Android's AR core, or game development engines like Unity or Apple's AR kit, etc. Next we have to, so if you are talking about AR and VR, you need to think about what is the hardware that you're going to use, what is the headset you'll need. Whether it's just AR, then what are the phones that you'll support, which phones can actually work with our technology that we have. So we need to finalize that. So based on that, you then change your if you have to change your application, you need to change it for that. So once you have these finalized, that is when you go and do a pilot. You go and deploy it to specific users, a small subset of your actual users. You do a user acceptance testing, whether, and then once the feedback comes in, we put in that feedback back into the application development, and then that is when we start industrializing it. We start hardening it, and we make it perfect. We reduce, shrink out the bugs completely. And once that is done, we can then go ahead and plan the rollout, talk about monetization, deployment, etc. So I'll now hand it back to Anur, who will take us through what are the key skills required to build XR applications.
Yeah, thank you, Pradeep. So yeah, let's talk about the key skills to build XR applications. So an XR application is not your typical web application or the Android or iOS application, because it inherently involves some level of creativity, and you can consider it as an application which has an element of a game in it. So that's why you will also find a lot of gaming professionals like myself who also sort of port over, who also can work on XR application development. So amongst the key skills that you find that you need, which are usually not required for enterprise application development, are 3D and 2D creative asset creation. So this is usually done in tools like Maya and through 3D Studio Max, Adobe Photoshop. However, I mean like I said, an XR application typically is going to be an application which involves some level of creativity. You're not going to have a simple, plain and simple 3D asset, in your application. There are going to be some. It's going to be a creative, interesting, fun by definition. So for that, you need creative 3D asset creation skills. Typically, you can find these professionals working in the animation industry as well, I mean, animation and gaming industry. Uh, then you have the SFX and background music creation. This is usually done in tools like Ableton Pro, FL Studio, etc. Uh, so again, this skill is not something that is very typical in traditional enterprise application development. An XR application will tend to have creative elements, like I said, and especially for a VR application, you will definitely need to have some background music and sound effects. You cannot just throw a user into a virtual environment, close the user out to all external input, and then have total deafening silence over there. You will definitely need to have audible feedback for actions that the user performs, as well as some background music maybe for which plays around and removes that sense of that deafening silence. Again, these professionals can be also can be found working in industries like music, the music industry, or the animation industry, film and television industries, etc. Then we have the traditional web application, traditional skills which are also found in the traditional application development, like with the web application development skills, then the backend application development skills like API development using Node.js or Java, etc., and the database development skills, which could be like the SQL skills, the Neo4j relational data, sorry, the graph-based database skills, etc. Uh, then next you have programming skills, the core skills, the key, the glue that keeps all of this together is the programming. So when it comes to programming with game engines, you have the primary chief amongst them are Unity and Unreal, like I said. One more point let me mention about Unity is that Unity is very closely collaborates with the smartphone manufacturers. Google I/O very often in the Google I/O, the conference that Google conducts for its developers throughout, once every year. Very often it features, highlights the collaboration that Google does with Unity. So when you develop XR content with Unity, it's usually the programming part is done in C#. When it comes to Unreal Engine, it is usually done in C++ or their own proprietary tool called, or proprietary programming system called Blueprints, which is a visual scripting tool. To make it a little easier for everyone to understand, is like having blocks of behavior or code which can be joined together, which can be intertwined together to create more complex behaviors. Something similar to that is also available in Unity, and a lot like visual scripting tools are available in Unity as well. And in addition to what you get in Unity by default, there are a lot of extensions and there are a lot of 3D assets, etc., available through the Unity's asset store. So probably for a very small prototype, you may even not reach out to any of the 3D, and you may not require specific 3D creation, asset creation, or sound effects or background music, and you can find all of this, a lot of it, in the Unity asset store itself. Now, when it comes to programming on the native mobile platforms like Android and iOS, Android is primarily programmed in Java or Kotlin, which is which is a recent introduction into the Android development kit, and it is fast catching up in terms of popularity. When it comes to iOS, iOS applications are developed in Swift and Objective-C. Now let's come to another important aspect of creating XR applications, which is the challenges that a team would usually face in developing XR applications. Now, since this is a very new field, there are the kind of challenges are also non-traditional. They're not very typical, so to speak. The first one, however, is a typical problem for any game developer, which is to be able to achieve a very high frame rate. As any game developer will tell you, a very high frame rate is very important. A VR developer will emphasize on this point even more. Since the user is experiencing, so first let me talk about the challenges that one would face in the world of VR. Typically, any frame rate below 90 frames per second is going to be very discomforting to the user. So it may even cause the user to be disoriented, and to the extent that the user can actually feel physically uncomfortable and nauseated. This happens. This for To understand why this happens, one needs to understand how the human psychology works. But this is not a topic of discussion for now. So, one thing is to re-emphasize: frames per second is very important, and you need a very high 30 frames per second to be able to offer a smooth experience in virtual reality. Again, the behavior of controllers needs to be intuitive in VR, especially. This can also cause disorientation. Your movement in the virtual world should match intuitively the usage of controllers. So a forward motion in the forward press in the controller should actually correspond to a exactly straight forward movement. Otherwise, it can cause discomfort. It can cause disorientation. Context changes need to be very slow. Otherwise, you don't actually switch context in the real world in a snap, right? I mean, you're not sitting in a meeting room at one instance and then suddenly in the next instance you are on a hilltop. This can very easily happen in VR, and that's why we need to guard against it. So this is the kind of challenge we have sort of overcome by having regular fade ins and fade outs and making context changes slow. This is a typical problem that most of the teams working in VR solve in this manner. Again, the hardware is clunky. So when it comes to VR hardware, often we have to face the problem that users will have to step over wires that are laid out all over the setting, because you need those sensors to detect motion properly. So the VR experience that we try to design involve do not necessarily we try to avoid the jerky movements, the movements in which the user collides into the sensors or trips over the wires. So the physical movements that are required, the gestures that are required from the users also have to be designed and carefully thought through. Then again, let me now shift the focus to AR, the challenges that we usually face in the development of AR experiences. And the glasses in AR usually are fraught with the problem of low field of vision. A field of vision is the extent to which you can view reality at one go. So for the HoloLens, for example, the HoloLens 1 had a low field of vision of 34 degrees, which is now improved in the HoloLens 2 to 52 degrees, an increase of 18 degrees. So that again creates a problem. Once the user looks beyond the defined field of vision, then you cannot see anything beyond that. No AR content is rendered beyond that. Another problem with AR is that the glasses do not render very well in bright light. So if you take a AR glass and walk into the sunlight, it'll probably be hardly be able to notice the AR content being rendered on the glass. Now, some of the challenges faced by VR, VR hardware being clunky and heavy and being restrictive to one place, are being attempted to solve with untethered VR, and the Oculus Quest is a case in point. It has solved to a great extent the problem of clunkiness. However, there are limitations to that. The untethered VR is still not there yet. I mean, you don't have the kind of finesse when it comes to tracking of motions or even the rendering quality. So let me conclude our webinar with by talking about a few points that we may not. Yeah, so we'll take away from this. So augmented and virtual reality is definitely the next big thing to increase the efficiency and productivity of an enterprise. Like my colleague Pradeep said, the enterprises are flocking to it, and it is only a question of when and not if for any enterprise to go in the direction of adopting XR technology. Now, although hardware is still not at the desired level yet, but it is extremely evolving extremely fast, with very big players in the hardware and software market putting in a lot of money muscle and a lot of research and development. Big brains are working behind it. So AR and VR software and hardware is bound to evolve very rapidly into something very into a scale of mass adoption. So in the United States, the XR tech is being, and even elsewhere, it's being used in a wide range of industries like manufacturing, construction, architecture, healthcare, education, and entertainment.
Yeah, this is Pradeep here again. I just wanted to add these 2 points here. With the new technologies like boundless XR with 5G from Qualcomm, and 5G being allowing you for lower latency, it will allow us to build content and stream it to XR devices. It also allows you to reduce the clunkiness, as Anur says, with smarter and lighter XR glasses. AR in is already mainstream in multiple domains like social media for filters, etc. And it's surely going to make bigger waves around the world in personal consumptions. So I'll hand it back now to Mark, who will take over.
Yes, thank you, Anor and Pradeep for sharing your insight with all of us. What I'm going to do now is post our third and final polling question, which you should see on your screen in a second here. Let me launch it. Again, we'll allow 20 or so seconds now for people to submit their answers, and then we'll close the presentation portion. Great, thank you, everybody. So, and thank you again to Pradeep, both to Pradeep and Anor for that information. Extremely informative. So hopefully, what's come across to everyone during this webinar is not only our learnings, but our approach in our delivery capabilities for enterprises looking to leverage the value of augmented and virtual reality. Before we close, I'd like to just share a brief overview of who we are here at InMinds. We're a product engineering firm of over 1,200 people. We're headquartered in San Jose. And our strength is really our ability to take our clients' requirements, specifically here as it relates to creating positive user experiences in AR, VR, and demonstrate quick wins along their roadmap. Our primary focus is on devices, applications, and analytics, with the integrated expertise and ability to build IoT devices, connect those to the cloud, develop apps to manage those devices, run predictive and prescriptive analytics for our clients as well. So really providing those end-to-end capabilities throughout our clients' AR, VR journey. Our IP that we've built really differentiates us as well and accelerates our clients' speed to market. And our services, which you can see here on the screen, help technology-focused clients design, develop, and deliver innovative solutions. These practices include devices, applications, analytics, as you can see, UX design and UI engineering, cloud and DevOps, quality and security engineering practices as well. So this concludes the presentation portion of the webinar. We'll now open it up for questions from all of you. As a reminder, as I stated at the beginning, you can submit your questions if you haven't already through the control panel in the question box. The chat box as well is an option. So let me share with our panel, Anor and Pradeep here. Let's start with the first question. Let me pull it up here for you. So our first question: how cellular connectivity embedded in the HMD is impacting AR, VR, XR devices?
Yeah, so I'll take this up. This is Pradeep here. So cellular connectivity currently is at 4G, and the speeds with which we have at 4G is still not that low latency for multimedia transition, transfer. For example, if you're on a desktop or high-end system and it's generating graphical content or multimedia content that you would view on a HR on your HMD headset, and that transfer is still not possible without a cable. And with cellular connectivity coming in and 5G coming in, that makes it much more easier. 5G connectivity base, the minimum bandwidth that you get is 100 Mbps, and that's it's good enough. In fact, it's more than enough for high-end or high definition multimedia transfer.
Great, thanks, Pradeep. Our second question: what type of hardware security implemented in AR, VR, MR devices until now and going forward? What will change in that regard?
Yeah. So actually, this is something that Qualcomm is actually working on with their new chipsets. In fact, I was talking about boundless XR, and the kind of security that so with 5G coming in and the headsets becoming untethered, technology will, I mean, the whole mobile based security will come into the headsets also. And I think this will so currently, which is not in practice at all, and I think the whole mobility security that you have will automatically move on to your headsets too.
Got it. Great.
Yeah.
The third question: what is the typical timeline for the development of a VR application, and is it similar for an AR project?
I think Anur, you would like to take this question?
Yeah, well, it all actually depends on the kind of requirements you have. But typically, the what we have seen during the course of our engagement in XR development is usually it takes about 3 to 6 months for a very simple AR application, to anything about a year for a slightly more complicated AR application. When it comes to VR, it's a slightly more engaged development process, because you are creating an entirely new virtual world, and there's a lot more that you need to do to get a VR application going. So typically for VR, I would say the timelines start from anything about, I mean, that is for us, that is in our experience, about 8 months to more than a year and a half.
There's also about there's also about the kind of features that you have. For example, earlier we were talking about this app for retail where you point the camera to a product and it'll give you a comparison prices from different online sites. So these kind of scenarios would not take that much time. Typically, maybe a month or two max, and you could build one such use case. But as you add features, to this kind of a solution, you start tending to add more time also and budgets.
Answers your question. Yeah.
Great. Thank you both. And what is, as a follow-up to that, what is the ballpark budget? This is another question asked. What is the ballpark budget to develop a project in AR?
So it depends. So for example, if you're building an AR application can be built, there'll be the cost of the developer, and based on the number of features, you might add one, two, three developers based on use cases. And then there is the cost of the UX, the graphic design for the 3D content, and some of the features. For example, if you take a typical cost would be like for a 3 months scenario, you have cost of the developer plus some content developer cost and deployments.
Great. Next
Yeah.
question: Will AR fuse online and offline shopping?
Yeah. This is a very good scenario. I think it actually makes sense. With Google Glass tried to attempted to do that. There are scenarios where you can fuse. In fact, we are working with one company right now that is actually doing online to offline profile mapping. And yes, that is the next step into where you could use AR, where it fuses the whole online to offline scenarios. And for example, if you're a voracious user of a reader or books and all, so as soon as you enter a particular location, you could get notifications on the nearest bookstores. And once you reach that bookstore, you can go point your application and then find the reviews of those different apps or books, and then buy whatever you want. Or for example, you could order it online from another store, or you could if the book is not in store, you could ask them to deliver it to your home. Yes, that's a very nice question, and looking forward to such fusion.
Great. And now, next question: Is it possible to convert an existing 3D game simulation into a VR experience? And if so, what will that entail?
Yeah, definitely. I'll take that. So yes, it's definitely possible. It's actually since you have all the assets. I mean, a game, a 3D game or a 3D simulation already has everything that you need for a VR simulation, except for maybe you may have to, create so if a game is already built in a game engine like Unity, then it is a very small effort that is required to actually give it the game VR capabilities. Only thing that you need to make sure is that maybe you need to restrict the movement of the user in certain cases where there are no 3D assets available, or maybe even when the user looks up, maybe you'll have to have some 3D assets there, maybe a skybox, something called a skybox, to fill in the empty spaces where a user would not typically look in a game. So it's very much possible, especially when it comes to a game engine like Unity. But when it comes to an iOS or Android game, or even when it comes to Unreal, it is very much possible. When it comes to an Android or iOS game, well, we have not encountered that scenario till now, but it's surely, the given the parallels that you have between VR and and the game and a typical game, that should not be too much of a problem. I hope that answers the question.
Thank you, Nora. So this is looks like to be the final question. This is an interesting one. Will this cellular modem embedded in the HMD devices affect users as an RF component, being so close to the brain?
Yeah, so I'll take this question. I think this kind of questions have been talked about, and there are a lot of articles, a lot of research that is being conducted. Uh, with current systems, like forget about cellular modem embedded in an HMD device. What about mobiles? We talk on the phone, continuously. What about those RF frequencies affecting our brain? What I would say here is too much of anything is bad, and especially with 5G. Yes, 5G is. Some of them claim that 5G is more dangerous than others, like 4G connection, because it uses ultra high frequency and ultra high intensity. But again, I mean, there's nobody who has proven that modem signals and cellular signals have affected people. So until such proven things come up, what I would suggest and what everybody suggests is use it as little as possible wherever required. Too much of anything is bad. I think that.
Thank you, Pradeep. Looks like we just had another question submitted here as well. Have you worked with the RealWear AR device? What kind of applications did you develop for it?
Yeah. Yes, this RealWear AR device is something that we worked with one of our customers to building that repair and maintenance solution. The RealWear device is actually an Android device. It has Android embedded. It's got a small screen, and the small screens. It's just like it's similar to a Google Glass. It's and that screen is and actually the whole device is controlled via voice commands. So you open an application, you go into the application, and then you do whatever, you call up somebody, and these kind of different scenarios through voice. And yes, that's how we built it. So a remote engineer, as I said earlier, the remote expert setting can view what the actual field engineer is doing through the camera of the RealWear device. It's a battery powered device, and yes, that's a pretty good use case that we are solving for automobile industry.
Great, thanks, Pradeep. Just had another one come in as well. Do the users using VR equipment need to have a technical background or be good with computers? Can someone like a construction worker, for example, use VR technology?
Yeah. So no, there is no need. There is no need for any technical background because, for example, as I mentioned earlier, the RealWear device is voice controlled. So you don't need to have computer knowledge or any specific technical knowledge to use the application or the VR equipment. And just put if it's an AR solution, you just use it normally. It superimposes on top of the real world. So there's nothing specific technology to learn to use the VR devices. Yeah.
Got it. That's great. Pradeep and Nora, thank you again. That looks to be the final question that I'm seeing here in the panel. So to everyone that submitted questions, thank you again for doing so, and thank you all again for joining our team today. What we hope is that you found value in the time spent with us and have come away with a better understanding of not only the AR VR landscape, but its real potential to benefit your enterprise. So if there are opportunities for us to help in that journey, please do reach out to us. We certainly look forward to continuing the conversation with you. From all of us at InMinds here, on behalf of Anor, Pradeep, and myself, thank you very much for your time. Thank you very much for your questions. Have a great day, everyone.
Thank you, everyone. Bye.